Okay, everyone. I believe you're enjoying the day. It shall be a great day for us in Jesus' name. Okay, today we'll be talking about waves and sound motion. So, this is a particular topic in physics whereby we mostly say kind of questions there. So, we're going to be discussing about that. So, now listen to what I'm going to define. So, we need to understand what waves and some sound motions and these are examples we're going to solve today. Do you understand? So, wave motion is a means of transferring energy. Is a means of transferring energy. I say only wave energy is carried forward, but not the medium. So the medium is not carried forward; it's only the wave that is what carried forward. Do you understand? So what is wave? Wave is a disturbance which travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. Do you understand? So there's something you cannot be asked there. It's something we call wave front. Wave front. What does it mean? It says is a line or surface in the path of advancing wave on which all the particles are in the same phase or state of disturbance. Yes, let me come again. Say line or surface in the path of an advancing wave on which all the particles are in the same phase or state of disturbance. So there's something we also call a cycle. A cycle is a complete to and fro movement or oscillation or vibration of a particle of the particle. So whenever you hear something, a cycle, oscillation, vibration, they kind of mean the same thing. Do you understand? So there's some terms you need to know. There's something we call terminologies. So we have terminologies. Terminologies. Do you understand? So there's something we call F, that's what for frequency. That is for frequency. We have a lambda, is for wavelength. Wavelength. We have a V, is for velocity. Velocity, or sometimes wave speed. We have T, is for period. Period. Now, period is given as the number of vibrations over frequency. Take note of that. We also have our amplitude A, amplitude, and we have distance. This time, distance is given as S, which will be VT. Do we understand this? So, yeah, those things you just need to know. So, spare me minutes, I'm coming. Okay, I'm right back. So, since you already know this term, so you can check these terms in a physics textbook or any physics material you have. Do you understand that? So let's kind of solve this kind of question. They said the frequency of a vibrating source is, so frequency is always given in hours, wavelength is always given in meter, velocity is always given in meter per second, time is also given in seconds. Most times amplitude are given in meters also, and distance always in meter. Do you understand that? So they said the frequency of vibrating source is 450 Hz, and the velocity of the sound it produces is 330 meters per second. Find how far the sound travels when the source completes 50 vibration. So how far makes the distance? Do you understand? So vibration is that's what you use to get the time. So let's get started. So solution, let me say solution EG1. So they're giving us frequency as what? 450 Hz. They give us velocity as 330 meter, something like this. They give us number of vibration as 50 vibration. So now let's find for distance. So remember, distance is S is equal to what? VT. So now T is N over F. So to get T, so we're going to add N over what? F. So we have to make 50 over what? 450. That's what? 1 over 9 seconds. Do you understand? So they've given us V already, so let's just put it there. So we have S equal to what? 330 multiplied by 1 over 9. So when you do that, I think you should get something like this. Okay? Yeah, I think you should get something like 36.67 meter. So that's all about that. That's all about that. So let's kind of continue. Okay. So I think I should clean this. Yeah, I should clean everything. Okay, so now the second question is that a radio station broadcasts at a frequency of 300 kilohertz. If the speed v of the wave is this, calculate the period and wavelength of the wave. Very simple. So this is what you're going to do. We have solution. So they're giving us frequency. Frequency is what? 300 kilohertz. V is, that's the speed of light. 3 times 10 is about 8 meter. This. They asked us to find t, and they asked us to find wavelength. I'll pay attention. So this is very simple. Now, when number of vibration is not given, t is always equal to 1/f. I'll pay attention. So you can just get t like this. So we have t is given as 3. Okay, as 1/300 times 10 to the power of 3. I pay attention. Why is 10 to the power of 3 is because of its kilohertz. Kilo is 1000. So when you divide it, so you have something like, okay, you can have something like 1/3 times 10 to the power of what? 5. That's 0.33 times 10 to the power of minus 5. You can have 3.3 times 10 to the power of minus 4 seconds. I'll pay attention. You can have this as seconds. I'll pay attention. So now it's just to find lambda. So lambda is given as, we have frequency multiplied by lambda is going to give us velocity. I'll pay attention. So we've gotten, okay, they've given us frequency. So to get lambda, just kind of divide. So lambda is v/f, and that's what? 3 times 10 to the power of 8 divided by what? 300 times 10 to the power of 3. So we have something like 1/100 times 10 to the power of 8 over 10 to the power of 3. And that's 0.01 times 10 to the power of 5. So when you multiply together, so you can have this is 1/100. That's 1000. Let's check that. Okay, if I'm correct. So we have 1/100 times 10 to the power of 5. Yes, you should have 1000. So 1000 what? Meters. So we've gotten the frequency and we've gotten the what? We've gotten the 2. Do we understand this? So the 1000, you can convert it to kilometer. So you can have something like 1 kilometer. Do you understand that? So please don't mind. Let me correct it now. 1 kilometer. Do you understand that? So let's kind of solve the final question on this kind of aspects. Okay. So we have okay, they said a source of sound produces waves in air of wavelength 1.65 meter. If the speed of the sound of air is this, find the period of vibration in seconds. Period of vibration. So that's very simple. That's T. So they've given us a wavelength solution 3. Okay, let me use my normal stuff as EG3. So they've given us wavelength as 1.65 meter. They've given us speed of sound in it as V is 330 meter second. This. We now also to find the period of vibration in second T. So how do we go about this? So now let's create a formula to solve this. Remember I said something. V is equal to what? Frequency multiplied by lambda. And what's F? T is what? 1/f. Open attention. Yeah. T is 1/f. So we can use everything to find T. So we're gonna have so we can have what will be F? F will be what? 1/t. So here we'll replace it. So we have V is what? Lambda over what? T. Then you cross multiply. So you have TV to lambda. Then the Bible is about what? V. So T is what? Lambda over what? V. So what is lambda? Lambda is this. 1.65 divided by this 330 meter per second. So when this goes up, it's going to become seconds. So what's the total answer here? So 1.65 divided by 330, the answer should give us 0.005 seconds. I believe you understand this. I believe you understand this. I believe you understand this. So there's one more thing I want us to know about this waves and sound motion. So under waves and sound, there's something we call echo, and there's a formula for echo. So we have the formula of echo as the distance traveled by sound, like the distance traveled by the distance traveled. Now imagine in this building now, there's a sound that hits the wall and come back. So it has two forms of distance. The distance it travels to hit the wall, and the distance it travels to return back to me for me to hear what I'm saying. So we have the time under echo calculations given as 2d over velocity of sound. So under echo is given as 2 distance over what? V. You understand? Go T. So the time under echo is given as 2d over. So d represents the distance and v represents the velocity of the sound. So spare a minute. Okay. So there's one more thing I want us to know. So let me clear this. So there's something we call frequency in wires. So I want you to know everything you need to know to have good grades in academics and make your parents proud, your school proud of you, and your country proud of you. So frequency in wires is given as FO, is that proportional to length. So let's have this. Frequency in wires. Frequency in wires. Do you understand? So you may not understand this, but you understand it. So we have frequency in wires. FO is directly proportional, inversely proportional to the length. Directly proportional to the square root of time, and also inversely proportional to the mass. So FO is inversely proportional to the square root of the mass. So we have the general identification as this. The frequency in wires we have FO. So let's use FW, frequency in wires. So you're gonna have something like this. Multiply this, and this. So we have something like this. 1 over L multiplied by square root of T multiplied by 1 over square root of N. When you join everything together, you have frequency in wires as 1 over L square root over T over N. So if you understand that's good. So whenever I want to convert this constant, this proportionality to a constant, you try to identify that k is a constant. So introduce k here. So we have Fw is equal to what? K over L square root of what? T over N, where k is a constant. So you may not know where you will read this idea, but just have it in mind. The frequency of wire is given as this. F is equal to what? Constant over length square root of time over tension, sorry, not T. This T represents tension over mass. So for that, we come to the end of this video. I believe you enjoyed this video. Give it a thumbs up wherever it is. Give it, share a comment, and let us know how far we've gone. I really appreciate it. Thank you for listening. God bless you. Have a nice day. See you in the next video.